Dispersion measures how spread out the data is. Central tendency describes where data tends to cluster, where things tend to bottleneck, group up. Dispersion describes the spread of the data. We have two fundamental measures of dispersion available to us to use. One is range, that we've already seen. That came off a 5-number summary. Range talks about the distance between the largest and smallest values. Although that is an accurate measure of dispersion that we might have, it's not necessarily the best measure of dispersion because it uses the largest and the smallest values. And if those are outliers, then it gives you a distorted opinion about what the average deviation is, or the standard deviation. So there's a more sophisticated way to do it that doesn't rely upon potential outliers, called standard deviation. Standard deviation does pretty much exactly what it says. It describes the average deviation from the mean in a data set. Together, mean and standard deviation give us the ability to understand and work with the concept of normal distributions. Mean, we know, takes all the values, adds them all together, divides by the number of values. If I took test 2's scores and told you that the mean value was a 75, would that mean that all of you had a 75? Not at all. So everybody potentially, could some of you have had a 75? Yeah, but I wouldn't have expected all of you to have a 75, right? I would have expected some who were better than that, and I would have not been happy about the ones who were less than that. So standard deviation is going to look at not just where you are positioned, but also look at how you are related to the mean value, so it can compare you to other people's position in a distribution. Now that means it involves a little bit of arithmetic work if we're trying to do it by hand. It is a little bit challenging to do by hand. And I'll show you the formula, and I'll show you exactly why we don't want to be able to use it. Okay, so all the stuff that we're going to do on this section can be accessed pretty much through one variable statistics. So we're going to be looking at that first screen of data that we had again that has our mean value on it and has our summation of all the values, and we're going to be adding information about two other values that are on that screen, only one of which we're actually going to use. You have two values that the calculator will give you for standard deviation, because it doesn't know if you're dealing with a distribution with a set of data that's got everybody already addressed and accounted for in the problem, or if only some of the values are accounted for in the problem. If only some of the values are accounted for, it makes it a challenge to be able to say that the mean is actually accurate, although we hope it to be fairly accurate, or that the standard deviation is actually accurate. So standard deviation kind of gives us the ability to be able to hedge our bets, gives us a little bit of a margin of error. Give you an example of what I'm talking about. If I told you that I intended for next Wednesday to have an estimate of what the GPA of all the students of the university was going to be, would you be happier if I went out and I got 2 pieces of information to make that estimate, 20 pieces of information, or 200 pieces of information? If I only took 2 pieces of information, that would make my life easy. I'd only have to ask 2 students. Is that a good base for making a prediction about average deviation? Why not? Not enough, but also the 2 people I could have asked who could have been the 2 dimmest light bulbs on campus, or they could have been the 2 sharpest tacks in the pack. Either way, doesn't do a good job of measuring, right? Okay. 20? Better than 2, right? But with 15,000 students enrolled at the university, roughly, only 20 out of those 15,000 might not be a big enough sample. 200? Better. A little bit more work, because now I got to find averages for 200, and I got to use a formula on 200 data values. But generally speaking, the bigger the sample that we have, the more like the population it's going to be, because we begin to minimize potential outliers, extreme values, and we get values that tend to cluster in the middle a little bit more. So that's the difference between the two different values we use. S of x is a standard deviation which treats the data that you put in as though it was a sample, implying that there's some values you haven't got, so I need a little bit of a margin of error in my estimate of the sample. I need to be able to hedge my bets. Well, it's not perfect, but it's within 0.1 of a GPA value out there. It's within 1% of what it actually happens to be. That would be better than saying it's not a really good measurement and it's off by as much as 50%. So that hedges our bet. The second value is a value called sigma of x. That's the lowercase Greek letter sigma. The calculator makes it a little bit more rounded. It looks like a scripted O in there. This is designed for populations. We do not study populations in this class. All the data that we deal with is always considered to be a sample. Therefore, your calculator is going to give you this value. Don't pick it up and use it and say it's the standard deviation. Ignore it. We will always use the S of x value for our standard deviation value off of the calculator. Okay, so there's, let's see, of those 23 questions that were out there, 10 of them involve a video of some sort that you're able to look at. So there aren't really a lot of work that goes in there. That means the other 13 are going to target some of the concept questions as well as some arithmetic values that we end up doing. You're going to find very quickly that standard deviation is all about you being able to type a set of data into the calculator, you being able to run an analysis on it, and you being able to pick up the right value. But they also expect you to absorb some concepts, and at least 4 of the questions in the of those 13 you're going to have to be able to do involve some concept that's involved up here, and some other things. So a typical type of problem that we might see might give us something like this.